interesting that I wanted to share with you guys. I actually learned today. They found, so for those of you who don't know, they exploited some kind of file upload vulnerability on their web server. Don't know what it was, they won't release that much information, but there were, once they got in through whatever vulnerability, it wasn't a normal, like it was an actual problem that they exploited. Once they got in though, they established over 30 web shells just sitting on their web server. Nobody ever saw them, nobody found them, nobody checked. Don't know why. That says a lot about how Equifax security is going on their end, but there's not a whole lot of details other than that. But that persistence is ridiculous. Like, you should be able to see 30 connections going out of your web server. You just look. Like, it's not that hard to see. So that was very, very interesting for me to see, for me to learn that information, because that's like a big gaping hole. So that's kind of all I wanted to mention about that, because there were very few technical details released, and that kind of sums it up right there.
They also posted for their social media links to a phishing site.
That's correct. There was a white hat who registered a domain that was very similar to the normal Equifax domain for their post breaching stuff, where they were trying to help everybody out. And one of their people on their social media team accidentally linked the phishing link instead of the actual link. Now, luckily, it was not a malicious link, but it could have very easily fit that. So that was kind of embarrassing as well. So they're having a really hard time. Hopefully they can resolve that. And that's kind of all I wanted to say about that. The next couple things we're going to talk about, I'm going to introduce propane to you guys. I've talked about propane a little bit during the very, very beginning of our BBS semester. I only kind of mentioned it in my speech. Are any of you guys familiar with the King of the Hill style competition in that format? Okay, have you ever played, I don't know, like a video game, I don't know, Halo, and played the King of the Hill game type on Halo? Same thing if you have. That's a familiar construct. Or if you're going to go back to your old days where you were kids roughhousing, there was a hill, you push people off of it, whoever held the hill longest won. It's the same thing. So we actually have introduced this concept to security competitions. And there was a very renowned hacker who goes by, his handle is Iron Geek, and he made this super cool platform called Netcat Listener. I don't know why this won't present. But he made this platform called Net King of the Hill, and it was super cool. Oh, that's why. And he open sourced it, and it was super awesome. And he, there you go. And I haven't gone over the past month, just because I'm at school pretty much, but there's a DEF CON group that meets in Atlanta called DC404. And they use Iron Geek's platform, Net King of the Hill, to host an ongoing Net King of the Hill game. And the way the Net King of the Hill game works is that there are several vulnerable machines on a network. You connect to the network, you get into the machine, and you try to hold it for as long as you can, and you're scored based on a web service that's running. So you place what's called a team tag in HTML syntax inside the index page of the web server, and the scoreboard will score your service. And so as long as your team tag's there, you're getting your service scored. So it's kind of a red team and blue team event, so you have to have both skills, because you have to not only get in, but you have to lock it down so nobody else can get in. So it's a very good way to practice both sets of skills. The problem with Net King of the Hill is it hadn't been updated in 5 years. It was kind of not very pretty, and it didn't have a lot of features. And so I took it upon myself to try to rewrite propane, or to rewrite Net King of the Hill, and I came up with propane. If you get that joke, then great, we can be friends. It's okay. So propane is basically the same platform as Net King of the Hill with a lot more shiny features. So let's get into that. So like I said, it's a King of the Hill platform framework. It works the same way. It'll score a web service, and however long you are holding that target, the more points you get. It's based on Net King of the Hill, but it offers a few things that Net King of the Hill doesn't offer. It has plugin support, so you can do super cool things. You could turn this into a full-fledged attack and defense platform if you wanted to. Just write plugins for it. It's all written in Python, so it's really, really easy. We'll talk about the plugins and how you write plugins a little bit later. It's got better template support that Net King of the Hill previously didn't have. Net King of the Hill did support custom templates, but it wasn't like a full, it was like a single HTML page. So if you wanted to add like a crazy bootstrap template or something like that, you would have a hard time doing that. So I made that a little bit easier. And it's got a couple new features like timed events, so you can start and end your event automatically between a certain time frame. This is kind of what the scoreboard looks like. It's kind of hard to see, it's not a very good screenshot, but basically you can add any pages, customize your template how you want. This is the default template. It's got a rules page that has all the rules, and this is the main scoring page. So you'll see that we have a couple of boxes down here all being scored. A couple people are scoring on the boxes. It shows you the server that you're on, so you can start there. You know all these have to have web services running usually, by default. You can, that's what the propane accessories for, we'll get to that. But the default with the web server, you know these machines will have a web server, so you can start there. You can go look at the web page, see if there's a way to get in from the web server. Otherwise, you have the IP here. You can start scanning and doing your assessments and see if you can find a way in. But this is kind of how the scoring works. If you're at the top of the board, your name catches on fire, and it's cool. So yeah. So why did I make propane? Because Netcat the Hill is awesome, but it could do a whole lot more, and I knew it could. I was also inspired by CTFD, so if you've actually played the King of the Hill platform, or not the CTF platform that's on our website, it's based on a platform called CTFD, which makes running CTFs a lot easier, and it's super cool. And I wanted a King of the Hill platform just like that. I wanted it to be really easy to stand these up and run your own competition. So I was really inspired by CTFD to do something like that. Most attack and defense style or King of the Hill scoreboards are clunky, and you really don't have any source code for these. When they do it, because there's a lot of them, a lot of competitions host these, but they make their own scoreboards, and they have a lot of problems usually. And King of the Hill is really clean, elegant, and simple, and so it's a good foundation. And I didn't really have any other references to work with because a lot of times they're closed source. I wanted to make this style of competition more popular because I really like it. That's kind of all there is to that. And I really also want to give back to the information security community in a way that's different from like finding this vulnerability that's super popular, because it's a lot harder to do. But if you can make something practical for everybody to use, that's just as helpful. And I really wanted to try to give that a shot. So, like I said, it's based on Netcat of the Hill. In fact, all the core scoring code is basically the same, but it's not Netcat of the Hill. So Netcat of the Hill is a scoring engine. It's got some easy to edit configurations, a simple templating system, and it also has the cool fire effects. But Propane does a lot more. It's got the same scoring engine. It's got easy to edit configurations. It's got a more advanced templating system, plugin support for black and white lists, timed events. It's written in Python 3, which is really important. And it's got the same cool fire effects. So that's kind of like a brief distinction between the two. So how's it better? Well, the plugin support makes Propane endlessly extensible. So you can literally make Propane do whatever you want it to do. You could even make it not run Propane and make it run a fun game of Tetris if you felt like. You can literally do anything because it's just straight Python. There's not a whole lot of security implications taken to that consideration with that because it's all ran on your machine. So anything that you do, you open yourself up to. So it's your plugin's fault, not plugin's fault. So be smart when you write your plugins. The new features are cool. The black and white list and timed events are really easy to configure. And these are very useful features that Propane has that Netcat of the Hill doesn't. And Python 3, like I said, this is important. Netcat of the Hill is written in Python 2.7 or whatever. But Python 2 will reach end of life in 2020. That's less than 3 years away. It won't work anymore. You'll have to run an older system to run Netcat of the Hill. While Python 3 will continue to live on for hopefully many years more. So when Netcat of the Hill dies, Propane will still work. So that was a really important upgrade that we chose to make. So Propane features. So Propacks, we'll talk about that in a minute. Black and white lists used to register and ban users. You just add the team tag into the config. It's just a common delimited list, and it will do the black and white list stuff. It's kind of simple. You can use both at the same time over that kind of defeats the purpose, but you can. Timed events, 24-hour time format. It really only supports daily events at this feature. So if you wanted to run a week-long online competition or something, you can't do that with the timed events. You'd have to manually start and stop. But I'll plan to add that in the future. But right now it's a daily event, and it starts a countdown on the scoreboard so your users know how much time is left as well. And then once it gets like the last, I think, I don't know if it's like 5 minutes or what, it'll say final countdown, which is a fun little joke and security. If you ever get the chance to go to DEF CON and go into, on the last day of the CTF, the last 4 or 5 minutes, they start blasting final countdown over the loudspeakers, and it's hilariously entertaining. So it was just a little ode to that. So propane accessories. We only sell propane and propane accessories. These are plugins, they're add-ons, modules, packages, whatever you want to call them, but we call them pro packs. So there's your intro there. Here's a little bit more about them. They're just Python modules. That's really all they are. They're very easy to write. It's very, very little requirements to get started, and they can be very powerful because the world's your oyster. So it makes propane more of a framework. And you can do a lot. So you can write something to score a specific service. So if you don't want to score the web service, you want no web service on, you can make it score, I don't know, a SQL server if you want to. You write that. You can make it do that and override that. You can make a more sophisticated band script that's not just a list that users can spoof. You can make better fire effects, or you can, like I said, make a secret game of Tetris. The world's your oyster. So this is a simple pro pack. All it is. So we're going to kind of dissect this a little bit. In order, like I said, we'll come back. But in order to actually get this to run, there's a folder inside of the propane project. So when you download propane, there's a folder called ProPack. You make another folder with the name of your plugin, and inside that folder you make this init.py. And that init.py is where your code will go. So this is what goes in the init.py. You need your start function. So this is the same thing as a main. This is the only real requirement. You have to define start. Once you do that, do whatever you want. Example of whatever you want. Just print hello world to the console and the output. So you can write whatever you want here. It's super, super easy. So that's ProPacks. It's really that easy. So that's in conclusion. This was made for, I gave this talk at a fireside chat at DEF CON, I believe. So this was made more for that, so this stuff kind of doesn't apply to our club, but that's what propane is, and I kind of want to just introduce that because starting at the next meeting, I will be running this in the background of our meeting for people to hop on, and at the end we'll see who scored the highest and won. And it'll just be a fun thing in the background to do. So I just want to share that with you guys rather than just randomly introducing it at the next meeting. So that's kind of all there is there. Next up, we were going to do voting, but there's clearly not enough people here. So I'm going to talk with the rest of the executive council, and we're going to consider doing an absentee vote on the amendments because I've gotten a lot of feedback from members who want to be here but can't participate in the voting. They keep asking me, are we doing absentee ballots? I'm like, probably, but we'll have to see it. So this was the second try, and we'll talk further, and I'll let you guys know about that. If not, we'll just drop the amendments. They're not all that important. It was just some neat improvements that I thought would be helpful. So we're going to move on and get into the fun stuff now. So let me find my other stuff. Don't need this anymore. I do need that stuff. Okay, so this is going to be our first ever noob challenge, is what we're calling them. Let's see if I can find the presentation point. There it is. Awesome. This is the first noob challenge. I'm going to be coming in and out of this presentation a lot to actually do the hands-on stuff. So these, if you're new, these are going to be really beneficial things. These are basically things that you'll see, fundamental things that you will see on Jeopardy-style CTFs that will get you a foot in the door. Sometimes these are verbatim challenges that you will actually see. Sometimes it's part of a challenge that you should recognize and know where to go. So we're going to talk about ciphers, hashing, and encoding, what the difference are, how they look, different kinds of things that you'll see. We're not going to go real deep because a lot of these things, especially like hashing and encryption, go really, really deep, and we're not going to go that far. We're just going to talk about it in context of the CTF. Ciphers are a type of encryption. Hashing is a one-way representation of data in a fixed size, and encoding is just a different way to represent the same data. So simply put, for ciphers, it's just an algorithm for performing encryption or decryption. Common ciphers for CTFs that you'll see are Caesar ciphers, ROT13, or custom substitution ciphers. These are all kind of similar. Caesar and ROT13 both do this kind of weird rotation thing, and are both very similar, but the custom substitution cipher is basically somebody makes a custom alphabet of whatever they want, and they translate normal alphabet to this alphabet, and it's encrypted by that. So this is an example Caesar cipher. You can actually, so when it comes to solving Caesar ciphers, if there's a flag format, these are actually really, really easy to solve. For example, I know these first 4 letters are flag. Yeah, 4 letters are flag. And then these bracket syntax has the flag in it. So using this, I can figure out how many times this has been shifted over and figure out what my key is at that point. So I know I is what? FGHI, that's 3 down, so that's my key, so FLAGH. But there's a really easy cheater way to do this, and this is how you should do it for CTFs, because time is everything in the competition setting. So there are wonderful, wonderful ways. I'm going to copy that ciphertext. There's some awesome tools for CTFs that will make your life easier, and they're just simple online tools. Like demo will work. So we can say we want Caesar cipher solver. We're going to make my life easier. So it really is important that you understand how these work, but in a CTF setting, it's more important that you know how to use these quick tools. And if it becomes a harder challenge, then that fundamental knowledge is what you need to know. So if this was a much harder cipher challenge, you would need to know the fundamentals. But Caesar cipher is one of those things where I can give you guys a cheat code. So this is already really easy. We already solved it by knowing that first 4 characters. We could just shift everything over 3 characters, and there's our flag. But if you want to be lazy, like I am, you can just Google Caesar cipher solver. I think this is one of my favorite ones. You can tell it what key to use and guess. In fact, this one gets the key wrong, but it always solves it. So as you can't see, there's your flag. So these are really awesome tools that you should always use in CTFs, because you will solve it so much faster than the dude who just did it by hand. So
it just checks?
It checks for every possible key that it could be, picks the best one, and goes from there. But if you shift this down, I guess 23 is also right, because you could shift either way. But if you were to shift this back 3, you would get FLAG, ET, 4, TU, EURT. So that's the flag, and it's really that easy when you see these kind of challenges. And it's also important to notice what kind of, you can't even come to this conclusion to start Googling Caesar cipher tool if you're not sure what kind of cipher it is that you're looking at. And it's kind of hard to tell. Sometimes encrypted text may be using XOR encryption, and it'll look just like this. You've got to just try different things. If it doesn't work in the Caesar cipher solver cracker, try it in a different kind of solver. Like maybe try a substitution, or maybe do some analysis on it. There's some great analysis tools as well. And if that doesn't work, you can try XOR and brute forcing the key. But if none of those things work, you're going to have to take some more steps. But we're not going to go into that, because like I said, this is just very basic for complete beginners. This is how you would go about doing something like that. So that is your Caesar cipher. Let's talk about hashing, I think is next. All right, so just like I said, hashing is a fixed way to represent data without using the data itself. It's great for password checking. All the web apps you use will hopefully be hashing your passwords before they store them in a database and not storing them in plain text. So there's a couple different types of hashing algorithms. You have Md5, SHA-1, SHA-2, SHA-3. Md5 is what you'll see 90% of the time on CTFs, because it's vulnerable to collisions, and there's a huge database for dictionary attacks that make comparison a lot easier. So they just do that just for the purpose, so it's actually more easy to solve. But in the real world, you'll probably have more, like people probably use SHA-3 standards. But there are still some operating systems that have Md5 as the default hash, and so where this is applicable is if you get into a machine, or if you're able to dump the shadow file, you will be able to see the password hashes. If it's Md5, there's a chance you can crack the password and just log in as that user. But a lot of more modern operating systems aren't using Md5 anymore. In fact, I think Ubuntu is up their standard as far as popular Linux distros go. But yeah, so this is an example of Md5 hash. There are a lot of ways to do this. There are some built-in tools for Kali, such as John the Ripper or Hashcat, that will help you crack this. But there are also some arguably more useful online tools. So I'm going to show you guys another online tool that I like to use. If I can find my mouse. So if I just put Md5 cracker to the Google one. It's CrackStation is a good one. There are a lot of these too. And it's basically just an online dictionary that will take your hash and try to see if there was a match for it. And they have these lovely captchas so you can't just brute force. So if we try to crack this hash, see what it is. There we go, match. So, hash crash override, that's your flag. So recognizing Md5 hashes is a little bit more difficult, or recognizing hashes in general is a little bit more difficult because you could say this is a very, very tiny base64 encoded string. It kind of looks similar, but there are ways to differentiate. Usually, we'll talk about base64 in just a second when we talk about encoding. There are ways to differentiate, but the way I go about doing it in a competition setting is to basically plug it in, and if it spits out something in one, then great. If it doesn't, I'll try the other, and if it's neither of those, I'll do more research. So when you're approaching a problem, just try. If it looks like what you think it is, if it looks like this, it may be an Md5 hash, it may be a completely different hash, or maybe it's base64 encoded, who knows. You don't know until you try. If you read too far into it and try to dissect it and actually figure out accurately, you're going to waste time. Whereas plugging it into something that can check it is going to be a lot faster in terms of competition. So that's why I'm not trying to introduce, like, you don't need to understand what these things are, but I'm trying to show you this is how you do it in a competition, because a lot of people aren't in that mindset, and that's how you get points quick.
Can I give a hint?
Yeah, sure.
You can look at the length of it, because those are hexadecimal, and every hash function has a fixed number of output bits. So this is apparently not SHA-256 because they're in 256. So you can put it in a Word program and count the number of characters there, multiply it by 4, and it tells you what's the hash output.
Okay.
And then you can just eliminate the ones that never give that output.
Oh, there you go. But so there's your hashes. Let me see. The last thing we're going to talk about is actually the easiest. So hashes in general. Ciphers or any kind of encryption is usually a lot harder to crack than encoding. Encoding, and I kind of should have started with this because this is really the easy babies first, anybody can do this, because it's just a different way to represent stuff. So, for example, ASCII to binary is a type of encoding. You can write the same thing the same way. So I can represent A as 0x41 in hex, or as this binary number 01001, or 65 as a decimal. It's all A. They all mean the same thing. I can just swap them back and forth. It's just in different formats. Base64 encoding is another common type, and it's used a lot in CTFs. And it's in commonplace. It's used in JSON Web Tokens. So if you're familiar with those, JSON Web Tokens are used sometimes for kind of like session cookies and session IDs. When you log into a web app, if they're using JSON Web Tokens, when you log in, you'll send your credentials and it'll send you back a JSON Web Token in your cookie. And JSON Web Token is divided into 3 parts separated by periods, and each part is a base64 encoded string with different information that it uses to resend to the server to fetch down more data if you visit a different page or something like that. So it's very common in web apps. So if your cookie has a base64 encoded string and you want to know what's in the cookie, you just pull out the base64 encoded string, decode it, and see if there's anything in there you can play around with. Common sign to let you know that this is a base64 encoded string is there's a big fat double equal at the end. This isn't always true. In fact, I'll show you that I think there's an example why as we do this. But this is an example of a common challenge that I see. I call it a rabbit hole. but this is what you'll see a lot on CTFs. So we're going to take this base64 encoded string, and there is a lot of ways to do this. I think I'm actually going to use the command line base64 decoder in this case just to see if it'll do it, but there are online tools for this as well that are also really useful. But we're gonna why did that get all that all of a sudden? What did I do wrong? I don't know what I did wrong. Okay, whatever. This didn't work for me last time either. I tried to, yeah, when I tried to fix do that. So zoom in. All right, cool. So hopefully that's not too dark. Yeah. Oh, come on now. Are you serious? All right, we'll try to not go super full screen so not be weird on us. Okay.
Is it the brightness sensitivity on your monitor, on your laptop?
Don't.
It might be the brightness of the TV. It might not be able to output it that much.
Yeah, maybe not.
For whatever reason.
So we'll do this. Basics4 is usually in most Linux distributions it's a command line tool. It's been built in so you can basics4 encode decode stuff. So basics4-d is our argument decode. We'll do some input redirection and pass in our basics4 encoded string. Okay, well this is another basics4 encoded string. Let's see, this one doesn't have double equals at the end of it. And so it's kind of hard to tell. So this is one of the rabbit holes. What's happening here is this, our initial string has been encoded multiple times. And so if we want to get to the flag, we need to decode it multiple times. So this, it's usually better, if you can't get it after the first 4 or 5 reverses, you should probably write a program to iterate through this for you, because otherwise they could have encoded it 500 times and you won't know until you get there. But in this case, I know it hasn't been encoded that many times, so I'm just going to keep going. I did too many little things. All right, we have another one. Like I may have, no, there we go. Good. There we go. And this one's a little bit more obvious that it's basically front coded because we have a double equals again. So I'm just going through this process. This is how you would go about doing that, and then there you go. There's your flag.
So if it has a double equals at the end, is that pretty much guarantee that it is basically?
Usually, yeah. It's pretty much a dead giveaway. Now, I did see something really, really tricky where there was a challenge that looked like it was basics4 encoding, and it was not iterative like this at all. It was just one encoded string. People struggle for hours and hours trying to figure it out. It's because it wasn't basics4, it was base 32. And nobody uses base 32 encoding for anything. And so it was just not common, but it was just as easy to do and decode. It wasn't secure or anything. It was just not common, so people didn't think to try it because they were used to seeing this. So keep that in mind too. Maybe if it looks like basics4, but it's not working, try base 32, maybe it'll work. So that's kind of our new challenge. Is there any questions, anything you want to go over or try? Or
I guess even if it's encoded multiple times, how would you? I mean, obviously you can loop through just to decode, but what kind of? I guess what would you look for to determine when to stop?
If you see that, well, first off, if it doesn't decode, then it may not be a basics4 encoded string. Second off, if you decode it and it looks like maybe a hash or something instead, you may want to stop because if you're trying to decode the hash, it probably won't work, and you have to go from there. Because sometimes people basics4 encode a hash that you have to. It's like something super common. Basics4 decode, it codes to Md5 hash. You get the Md5 hash out, but it's a Caesar cipher, and you have to go to the Caesar cipher and it just spirals down. So once you start noticing changes in the output, and especially if it just stops basics4 decoding, there's your sign. These are a little bit less difficult to kind of do error checking on.
Do you write scripts to, for example, do the iteration?
Mm-hmm. Yeah, both when building these kinds of challenges and solving them, it's much better, faster to write scripts, especially if you don't know how many times it's been.
Or are there tools, for example, that does it for you and it recognizes the flag, for example?
In this case, I don't think there is. There could be. Somebody could have written one, but that's actually probably really easy to write because all you have to do is make a quick Python script, write a for loop, and then run this command in the script, and then grep for flag. And it would print out eventually. And that would be a good way to go about writing it. Well, now we'll move on to our hands-on challenge, and I hope it works.
I did have one other question. So whenever you're looking, so flag that's common for that to be. I mean, that's pretty standard. Would you say that if you're looking for something, it's labeled by saying flag?
Usually, yeah. Especially if a good way to go. Some CTFs are real confusing and have a number format that's just randomized numbers that you got to find, and that's smart for the CTF side, but it's very confusing for the end user because you may find some random numbers, but that might not be the flag, or it might be. You don't know. You gotta try, and if it's a competition where you lose points for wrong submissions, that can be problematic. But most of the time, there's a flag format, and it'll either be in the flag format I just showed you, or it'll be flag : something, or maybe if they're the name of their competition : something, or something like that. So yeah, the flag format is usually pretty standard.
Gotcha.
I haven't really seen a whole lot of variation.
So that's how you would determine when to stop on your script, is if you find a flag.
Yeah.
I got you.
And that's actually, knowing that information is also how you can more easily solve things like an XOR encryption challenge, because you know exactly what characters should be at the beginning, so it's easier to find the key. Your problem there will be figuring out the length, but that's easier to brute force at that point when you know it's at least this many and at least has this at the end. So knowing your flag format will help you solve a lot of these kind of challenges. Alright, so let's see. I need to do some network stuff set up real quick. If you guys want to go ahead, if you're going to participate in the hands-on challenge, don't do anything yet once you're on the network, but there is a network open called Propane, KOTH. This will be the access point we'll use for Propane when it's actually set up, but I'm going to use it for the demo today. So go ahead and feel free to connect to that while I look for PowerPoint. Alright, so hey everyone. You may notice that this is completely different from the meeting, for those of you who attended. The screen capturing footage that I recorded in our initial meeting really sucked, because at the start of the screen capture I was doing this weird split monitor display thing, and it was actually recording it correctly, but because of my fear that it wasn't, I switched the display options, and then the recording never shifted with it, so it was real bad. So the bad sucks because I have to re-record this, but also a good thing because I can hopefully explain this a little bit better now that I'm not having as many technical difficulties. So I kind of get to cheat a little, and you guys don't get to see me screw up again. Alright, so this was the hands-on activity from our Black Box Society meeting on September the 22nd. We went over how to own a Windows XP machine. Owning, pwning, hacking, if you're not familiar with those terms, get familiar with them. Welcome to hacker culture. So enough with cheesy gimmicks. This is pwning Windows XP for Black Box Society. So we're going to start with the phases of a pen test. These are just very generic phases of a pen test. If you Google for phases of a pen test, you'll see these or similar steps like these on several links and articles and blog posts or whatever, but these are just very, very generic. Actual phases of a pen test will very much have differences depending on where you're at, what your team is, or anything like that. There's even really more in-depth methodologies. When I was researching this, I found like a whole paper on pen testing methodologies and the phases of a pen test, and they had like 8 steps, and it was ridiculous. But we're going to keep it simple, and we're only going to go over these first 3 that are highlighted in red. Recon, scanning, and gaining access. But again, these are just generic phases of pen test, and I think they work out pretty well for what we're going over. So we're going to start with recon. So there's lots of ways to do recon. Recon is reconnaissance. You are going and gathering information, intelligence gathering. So there's lots of ways to do this. Lots of ways to do this. You can get information from people's social media profiles. You can get information by Googling. You can do who is lookups on domains, find out who owns the domain, stuff like that. You can do like silent network discovery stuff, like we're going to do today. Of course, ours won't actually be super quiet, but there's all kinds of ways to do recon. It's just what information do you need and how do you gather that information, and that's your recon step. So it really just depends on the context. So for our purposes, we know we're trying to hack a Windows XP machine. We got that information from the PowerPoint, so phase 1 of recon is complete. So now what? Now we want to use NetDiscover to identify some potential targets. NetDiscover is a pretty neat little program that will allow us to passively scan networks, but we're not going to do the passive scan. So the way NetDiscover works, as far as my understanding is concerned, if somebody wants to correct me on the internet, then that would be helpful for everybody. But when you run NetDiscover, you send out ARP requests to all the machines on the network, and they give you replies, and from that reply you get information like their MAC address, their IPs, and their vendor name for like their wireless card and stuff like that. So you can identify the active targets on the network, machines that are actually connected to the internet, and you can do further scans. I think this is better and quicker than an Nmap scan. It's not quite as in-depth, but it's definitely a lot quieter than doing an Nmap scan on like a /24 or like the full range of IPs. You also have the option to do this passively. So when you do NetDiscover with a -P flag, which I'll look at kind of briefly, you'll see that you can be a little bit quieter. You won't send it when you do it with the passive flag. You don't send out requests and expect response. You just sit and listen and see if another machine happens to send a response to you. And over time, usually you'll be able to get most of the machines, and you'll have done it pretty quietly. So it's a pretty neat tool. So we're going to start with that. We're going to look at it so we can identify our target. Alright, so we're going to do a NetDiscover. Now if you were to do NetDiscover-P like this, it would do a passive scan, and that's kind of all there is to it. But we're just going to do NetDiscover just to make this quick. Alright, so we don't really care about anything else except for this IP. That's why I stopped the scan early. So I know this is our target because this is the vendor ID stuff for the VirtualBox host. In more practical application, you would kind of just pick an IP that you're targeting. Like if you wanted to go after this Apple device here, or if you wanted to go after the Samsung device, or maybe this device here, you could. It just depends on what you're trying to do, what you think your best input vector is. But in this case, I know how to identify my target and what I'm looking for because I know it's a VirtualBox host, and I know I'm running it on my machine, so I know that this IP will be it. Alright, so with that information in mind, we are going to move on to our next phase. Scanning. There's lots of ways to do scanning too, just like there is for recon. You can use Nmap, like we're going to do today. You can use fancy vulnerability scanners like Nessus or OpenVAS, or you can even use Metasploit to do scans. Metasploit has some pretty powerful scanning utilities that are pretty neat. So there's tons and tons of tools for scanning, and they all do different things. There's web vulnerability scanners. There's just full range vulnerability scanners. There's scanners that just look at specific services. Like there's tons and tons of tools and tons of ways to do scanning. You don't even need a tool to do scanning. You could just do like fancy curl calls or something if you're poking at a web service. It varies. So there's lots of stuff to do as far as scanning goes, but we're not going to use any fancy tools. We're just going to use the good old classic Nmap. It'll be plenty of use for what we're going to use it for. Vuln scanner is going to take too long, and we don't want to cheat with Metasploit just yet. So we're going to run Nmap. I'm actually going to use Nmap because I like the Nmap GUI, and also because I love the little presets that set in, so I don't have to really think too hard to remember the flags for like a quick scan. So I like this command. It's very quick because it's a quick scan. There's tons of different presets here. It's good to know your Nmap flags. In fact, if you see this little command right here, this is all that's getting ran in the background. If you just open a terminal with Nmap, if you're on a machine with Nmap installed and you run that command with your IP in place, it will run just like it will here. So it's literally the same tool with a GUI wrapper around it, and I like cheating and making my life a little bit easier. So I don't have to remember all these flags, but I can just remember key ones like -O. So -O is going to help a lot because it's going to help fingerprint our operating system. So it's going to try to guess what operating system our victim or our target is. They're not our victim yet. We haven't hacked their machine. So our target is we're going to need an OS identification on it to know how we're going to exploit it. Obviously we know it's Windows XP, but we want to confirm that. We also want to see what services are running. So this is going to run a very quick scan and try to guess the operating system. So let's run that. Alright, cool. So we see we have tons and tons of services open. So in this case, there's a web server running, there's a SQL server running, there's telnet running. We can just probe around. So say we want to connect to the telnet. We can go telnet at this address. Oh, hey, look, it's Microsoft login prompt for the telnet service. So we could totally log into this machine from this login prompt. Problem is we don't have any credentials. If this were maybe a scenario where we were on the network and there was an admin on the network, and maybe telnet is how they administer some of their machines sometimes to log in, you could sit here and sniff traffic and wait for an admin to log into the terminal, because the telnet traffic is going to be clear text. And at that point, you could just take the credentials you found and log right in through telnet, which would be pretty cool. There's an FTP server open, but unless it has anonymous login capabilities, we're kind of screwed there as well. We could try default credentials, and we can even try to do that. So if we open up our file browser and we go to other locations and we try to connect to FTP. So this is cool. You can connect to different web servers from this little prompt if you're using Kali Linux. The file browser is pretty cool about that. So you can just do FTP. I can try to connect as an anonymous user, and it's not working. And I could try to guess the username and password. Maybe it's something simple, but that's not what we're going to do today. We're actually going to do something a little bit more complicated to get in. But that's some examples of different things. We can go check out the web server. We got this XAMPP portal. Spoiler, so for when we start running the King of the Hill game that we're going to have, all the machines will need to have a web service running by default. This machine has a web service running by default. So while you're going to be able to exploit this machine if it happens to be running using the vulnerability that we exploit today, you can also look at certain things like this phpMyAdmin where you have root access to the database with no password. That's a very big entry point. Keep that in mind. That's another way to get in if somebody gets in and locks down the machine, but they forget about the web services because they don't want to break the web services, and they don't change the root password on this. This is another way to get into this machine. Okay, so anyway, enough fancy talk. Let's talk about gaining access. So just like I kind of went ahead of myself just to explain why we did that scan, looking at all these different services. Just kind of to show you how this information is useful. I did miss one point before we move on to gaining access. I missed this. We guessed for Microsoft Windows XP, and it found that this is either going to be XP Service Pack 2 or Service Pack 3. This is very, very, very important for later because the exploit code we're going to run doesn't have return addresses for Service Pack 2. And I know that may not make sense to you right now, but keep that in mind as we move forward, even if you don't know what that means. Okay, so gaining access. There's lots of ways to do this. Again, lots of ways to do everything with this kind of stuff. So for Windows XP alone, there are at least 10. There's probably way more than this. This is just me doing like random searching for CVEs and search exploit stuff. But there's at least 10 remote code execution vulnerabilities associated with Windows XP. There's probably more. Gaining access doesn't always equal using a fancy RCE.
RCE, remote code execution vulnerability, some terminology there. But gaining access doesn't mean you use your fancy RCE. Like we just saw, there was a SQL server open that had no root password on it that we accessed from a public-facing PHP-MyAdmin with also no authentication. So that's not fancy remote code execution. That's just poor web server management. So that's another way to get in. However, today it does, and remote code execution is fun. So that's why we're doing it today. So yeah, how do we gain access? Well, if we Google for Windows XP remote code execution, let's see what we find. So if we go to good old Google.com, and we Google for Windows XP RCE, what do we get? It's funny, when we did this during the meeting, we got like a lot of different things. Like I think this is a list here. I'm just gonna pick a few and see what happens. I'm not gonna pick that one, probably this one. And see if I can prove my point. I was able to prove it to myself, but every time I demo this fails. Alright, yeah, let's Google for a more generic term that somebody who doesn't know terminology might be. So Windows, so how to hack Windows XP ZP. That is not a version of Windows. Alright, Windows XP. Alright, so let's just pick a few different things. So this doesn't look like what we want. Let's retrieve passwords. This null byte thing. Just picking a couple random articles and see what we found. This seems like a really stupid article. So this is some Metasploit tutorial stuff. So I'm hard pressed to have my point proved, but if you say popular Windows XP, common Windows XP vulnerabilities, maybe this is going to help out. We'll just pick a random article again. So I'm trying to get it to show up with the exploit that we're going to use today, but obviously Google is not my friend. Yeah, okay, so I was trying to get it to pop up with this vulnerability, MS08067. For those of you who haven't heard of this, this is a classic vulnerability. In fact, there's this awesome t-shirt right here. In fact, I saw, I think his handle is Mantis. Me and Chris stumbled upon a foundational meeting of some sort at DEF CON with some really nice people. And one of the people kind of leading the group, his handle was Mantis, and I can't remember his name, but he was super cool, and he was wearing this shirt, and it was hilarious. This is just a classic reference to 08067, which is a critical remote code execution vulnerability in Windows XP. So there's my failed attempt again, that failed at the meeting as well, so of trying to prove the Googling point there. But most of the time you'll see MS08067, I would hope. Because that's really common and really easy to exploit and really powerful. So how do we find public exploit code for this? So for those of you who don't know, a dead giveaway for what service this is right here, I think. I believe port 445 being open on a Windows XP machine gives you a good sign that the NetAPI vulnerability is available for exploiting. So how do we exploit this? Well, we could reverse engineer the NetAPI DLL and try to figure out the vulnerability ourselves and write our own exploitation code and all that kind of fun stuff. But that seems real hard for something that has been exploited for many, many years. This isn't a fresh new vulnerability off the block with hard to find use cases and proof of concepts. This has been a proved vulnerability time and time again, so much so that why aren't we using Metasploit to execute this vulnerability? I'll talk about that a little later when we actually do use Metasploit, just to show the distinction. But we want to manually exploit this first. So how do you manually exploit stuff? Well, a good place to start is Searchsploit. So Searchsploit, if you've ever heard of ExploitDB, it is the command line tool for ExploitDB. It's a lot better than ExploitDB because you have to deal with captchas or a web interface. You don't have to be connected to the internet. It's super, super useful. So yeah, it's installed by default on Kali distributions, but I believe you can install on pretty much anything. So if you don't have it, it's a very useful lookup utility. So we're going to search for MS08067 since we know what we're going after. And we got a couple. So these are all proof of concepts. A couple of them have different benefits than the others do. Like this one's going to be for Windows Server 2000, 2003. It's a nice convenient Python script, but unfortunately that's not going to work for us because we're going after XP. This vulnerability also affects Windows Server 2000, 2003, just so you know. And there's all these awesome other stuff. So there's a Metasploit module, so this is the code that Metasploit uses. That's also kind of useful. This is another proof of concept code. This is some C code. But there's a lot of problems with all of these different proof of concepts. Some of them are really difficult to compile and all that kind of stuff. So our best friend is going to be this guy right here. There's some problems with it too, but for the most part, it's going to be our easiest public exploit code to work with. So all the public exploit code is located in this path for Searchsploit, and then at whatever the specific file is. So we're going to copy that, and do a CP for copy, and then copy the Python script, and I'm going to save it to my desktop as pwnxp.py. There we go. Now we can go take a look at it. Alright, so this is the public exploit code. It's a nice fancy Python script, and it's got some instructions inside. This is nice because sometimes public exploit code doesn't have instructions inside, and you're left to sift through the code to figure this kind of stuff out. So this is Searchsploit. You can search for lots of things with Searchsploit. So we just got that for later. Make sure you have that. We'll come back to that in a second. I want to talk about Searchsploit just a little bit more. So I can search for lots of stuff. Let's search for something I haven't tried to search for before. Maybe Android. Alright, look at that. We've got tons of vulnerabilities here. Potential problems with Android and specific devices. We've got like Linux kernel on Android. We've got some LG, some Google Android, which I guess is just Android. Let's try Searchsploit, maybe Mac OS. Think Mac OS doesn't have problems? Well, you're wrong, kiddo. Here's some tons of problems with Mac OS, and I think there's even some iOS stuff right here as well. So there are, some of these aren't like a big deal. Well, I mean, they're all a big deal, but like nothing, some of the stuff isn't fancy, you know, remote code execution like we're going to see today. This is just problems that can be exploited. I think there's some lots of privilege escalation stuff that gets to be really useful and stuff like that. But anyway, I just wanted to show you guys this. This is an awesome tool. I can search for just Linux, which is going to return tons and tons of stuff. You can get shell code from here. So it's not just vulnerabilities. Like this is where the bind TCP shell. We're going to talk about shells in a minute as well if you're not familiar with that. But it's just code that you can use. It's not necessarily always exploit code. But this is a full database full of tons of exploit code. So yeah, that's Searchsploit. That's how we got our Windows XP vulnerability. We'll come back to that in a minute. Now we're going to talk about shellcode. What is shellcode? So we have bind and reverse shells, and I'm going to kind of give you guys an introduction to Netcat. Unfortunately, because of the video corruption, I lost a great bit of footage where we had one of our members volunteer, it was Tyler, to kind of assist me with the demo for Netcat. So it's probably not going to work the way I want to, or I'm not going to be able to demonstrate it the way I want to because I don't have another machine to demonstrate with at the moment. So that kind of sucks, but I'm going to teach you a little bit about Netcat and about shells and stuff. So the concept of a bind shell, for those of you who aren't familiar with what a shell is, you're looking at one. This is a terminal session, also known as a shell, a command prompt. TTY, whatever you want to call. There's so many names. We just call them shells. A shell means you have access to control the computer from a command line interface. So Netcat is a awesome tool built into most Linux and Mac distributions. I guess most versions of Mac OS and most Linux distributions. And it is the Swiss Army knife of networking tools, is what it's commonly referred to as. And it is awesome. You could even host a full web server with Netcat. It is that freaking cool. So, yeah, so what we're going to do is use it to explain the concept of bind and reverse shells. And hopefully I can just do one on myself to explain the concept, but if you really want to get this working, you need to, or if you really want to see the power of this, you need to actually use a second machine. So I'm just going to open up 2 different terminal windows. There's different versions of Netcat. We'll talk about why that's important in a minute once we get to the binary reverse shells, but I just want to explain Netcat. So Netcat lets you make listeners and make connections to stuff, so I think I could actually connect to that one machine, that the Windows machine on port 22, I believe. Was that right? Was that the right machine? Oop, that's because it's not 22. I think it's 21. I don't know what port for telnet is. I'm an idiot. SFTP. Port 23 is telnet. Right? Okay, yeah. Port 23 is telnet, but there's no route to host. Am I using the correct IP? I'm not using the correct IP. That would be why. Okay, so try this again. We can connect to telnet with Netcat. Obviously, we're having some wonky issues, so we're going to stop doing that. But you can connect to a lot of stuff with Netcat. It's truly the Swiss Army knife networking tool. So we're going to listen on port 1337. So this is called a Netcat Listener. And these arguments are LVP. I'll explain them real quick. L is to listen, so it's saying, hey, Netcat, set up a listener to listen for and receive incoming connections. V is for verbosely, show me some output that stuff has been connected and stuff like that. And P is to specify the port, which is 1337. Over on this terminal, I'm going to do a Netcat to connect to myself. I've never actually tried this, to connect on port 1337. So if I hit enter here, I got a connection. And what's cool about this is you can do like a little chat app and say, hey, cool, alright. And if you were on another computer, you could chat back and forth with people. So it's like a quick little chat utility. This is over clear text, though. And that's where the different variations of Netcat come in handy. So you have SOCAT and NCAT. Both offer the ability to do encrypted traffic. Netcat by default doesn't. So that's something that's really cool. But yeah, I remember a couple CTFs we would set this up and we would do some basic chatting over the command stuff. But again, this is clear text, so you don't want to share flags or anything like that. It's just fun to do. So yeah, going to demonstrate some concepts. So that was representative of a bind connection, and really you could actually call that a reverse connection as well if you wanted to. Just depends on how you look at it. So if you look at it from this guy over here, me connecting to the other terminal, or me connecting to myself, pretend it's another machine. Pretend these are 2 separate machines. So this machine connecting to the other machine, just for the demonstration's sake. It's not, I know that's not accurate, but anyway. So from this machine, I connected to the other machine. That's binding. I'm connecting to it. It's not connecting to me. And I connected to it and did the chat stuff. However, if you look at it from this side, I set up a listener and say I hacked into this machine. I made it send back a connection to me. That's called a reverse connection. So I'm not connecting to it. I'm making it connect to me. So I know that seems kind of confusing, but it's going to make a whole lot more sense when we put the concept of a shell onto it. So a bind shell and a reverse shell. So if I So this is going to be the hacker man. This is going to be my victim, right? So hacker man is going to, we've hacked into this machine. We want to set up a backdoor. So what we can do is say, hey, on this victim, listen verbosely on port 1337, and send me your shell. So -E stands for execute. So we're going to execute bin bash on this machine. Set up that listener, and now if I connect to myself, or if I connect to my victim on port 1337, get a connection. If I type ls, I have a shell on their machine now I can control. So if this was physically a different machine, I would be on their machine being able to view the terminal stuff. So I can go into their downloads, and there's nothing there, stuff like that. So I can navigate around just like I was in a normal terminal. Alright, that's cool. So there's a problem with that though. That's called a bind shell. So I connected to the shell that I had set up on the other machine. That's cool and all, but what if there's firewall rules in place? What if I set up that on port 1337, but I'm accessing it from outside the network? Well, unless port 1337 is being forwarded through the firewall and is accepting connections, I won't be able to connect to that. So that's kind of useless for me. That's where reverse shells come in handy. So if I start a Netcat Listener on my machine, or my hacker machine, and I've hacked in the machine, I want to start a backdoor, and I want to install a backdoor, I can say, alright, Netcat, connect to me, connect to my hacker machine, and send me your shell. So I'm making it connect back to me, and during that connection process, I'm making it send me the shell. I left out an important detail. You gotta specify the port. So yeah, this is useful because a lot of the times firewalls may block different port traffic, so you can just change your ports around, or you can't connect from outside the network, but users can browse the internet. If there's no port restrictions, they can connect to whatever port they want to. Sometimes it just depends on the situation. You may have to do some more information gathering to figure that kind of stuff out. But generally speaking, if a user is allowed to connect to whatever they want, they can connect back to you. So you just host your listener somewhere on the internet where they can access it, and they just send you their shell, and then you have it. So, bam, they just sent me their shell. I got that connection. It lets me know, and there it is. I control their computer. So that's a reverse shell. So the first concept was a bind shell. So think bind, we're connecting to it. Reverse shell is them connecting to us. So yeah, that's Netcat, and that's the basic concept of reverse and bind shells. Now that's important because we're going to have to generate some shell code, and we're going to have to decide whether it's reverse or bind shell. So by default, I usually pick reverse shells just because of that whole firewall thing. It is pretty much guaranteed to work for the most part. That's kind of my theory on it, and so I kind of stick with that. But they're both equally useful. It just depends on the context of the situation. So now we're going to talk about NSF Venom. Netcat's great and all, but it has some restrictions and some limitations. For example, you can't listen in from multiple connections at the same time. You can't. Well, you can if you have like multiple terminals, but with one instance of Netcat, you can't do that. You can't background your session and come back to it. You can't easily transfer files. Well, actually, you can. That's a lie. You'd have to do a separate Netcat setup for that, but you could really easily transfer files in Netcat. So I'm a liar. I'm sorry. The biggest the biggest downside to Netcat, other than the clear text traffic, is that your connection isn't necessarily the most stable thing in the world. If either Netcat utility is stopped at any point in time, either A, you're not going to be receiving connections, or B, they're not going to be sending connections. So oftentimes it's better to generate an actual program that runs and executes your shellcode to do that kind of stuff. Also, sometimes exploit, in the case we're about to see, sometimes your exploit requires you to send shellcode. So you could send Netcat over, like the Netcat binary, the program, the executable, you could send that over. but unless you've got another chunk of code that says, hey, run it after you send it over and start a listener, you're going to have a bad time. So it's generally easier to actually have real legitimate shellcode that's just going to send you back a shell that's going to run. So lucky for us, there's a couple ways to get shellcode. So shellcode isn't exactly the easiest thing to write. I don't know how to write custom shellcode. That's something I would like to know how to do, but it's kind of not necessary. In 90% of cases that I've seen, the shellcode that or the way we can generate shellcode is gonna be more than sufficient. Using Searchsploit though, you can actually find some custom shellcode that's publicly available if you don't like the shellcode that we're gonna generate with the tool called MSF Venom. MSF Venom is pretty cool though because it generates it's a utility made by the same people who make Metasploit. And it goes hand in hand with Metasploit, which is really cool. But remember, we're not using Metasploit. We're just going to use some of the utilities of Metasploit. We are going to technically use Metasploit for our listener instead of Netcat, and there's a reason for that. But I'll get to that in a second. Well, I'll get to that when we get there, really. But yeah, so MSF Venom is an awesome utility, and we can use it to generate shellcode. Why do we need shellcode? We'll look at that in a second, but I just want to show you guys, if you do MSF Venom -L payloads, MSF Venom is kind of slow, but give it a second, and it will list all the kinds of payloads you can generate. There we go. So you got like 64-bit Windows, you've got your PowerShell, you've got Python, you've got Mac OS, you've got Linux, there's Unix BSD stuff, there's even Node.js. This is really cool. Kind of touch on this. I hope I just submitted a machine to. No, I can't talk about that. Never mind. I don't want to give anything away. But Node.js shell is super useful because you don't think of stuff like that. How can Node.js be exploited? Well, if there's a problem and you're able to execute some JavaScript, maybe it's running server side, try to throw a shell at it. It's PHP and all kinds of cool stuff like that. So yeah, it's really awesome utility that lets us generate shellcode. Why do we need shellcode? Okay, well now we're at the point where we can start talking about that Python script. So MS08 067. Baby's first remote code execution. It's also really, really fun. That's why we're doing it. It's most people's first real exploit that they go after. Of course, nowadays we actually have a similar exploit on Windows 7, Service Pack 1, codenamed Eternal Blue. I can't remember the MS number code name. I think it's 017 something or another. But we'll actually look at that another time, probably at the next meeting. But they're very similar as far as being scary remote code execution vulnerabilities. But even believe they're ran by a service on the same port. But MS08X7 is for Windows XP, and it is awesome, and I believe everybody should try it. It's just fun. And if you run into it, you should know how to do it. It should be something you know how to do like the back of your hand if you're going to get into this kind of stuff. Although I hope and pray this is less common in the wild nowadays than it was a couple years ago. You never know. But anyway, so thanks to Searchsploit and the lovely authors of the Python script, we can manually exploit this without Metasploit, and we can input our custom shellcode into it thanks to MSF Venom, start a listener, and then pwn the machine. So let me explain all this real quick. We're going to start with the custom shellcode concept. So we're going to look back at our exploit code right here. Why do we need shellcode? Well, in understanding why we need shellcode, we need to understand this vulnerability a little bit. And also, in trying to understand this vulnerability a little bit better, I can explain why the service pack thing was such a big deal. Alright, so this particular script has a couple different options. When you run it, you basically say, hey, script, attack this IP using this option. And your options here are 1 through 7, and they are all different service pack options. Why is this important? Well, because I think the net API vulnerability is a buffer overflow vulnerability. And so all of these different service pack options actually have different return addresses. So if you're not familiar with a buffer overflow, or if you're not familiar with buffer overflow, I am really not the best person to cleanly explain this, but I'm going to do my best to explain this in a manner that everybody can understand. So you should all be familiar with programming, otherwise why are you watching this? Why are you in computer science? You should be at least somewhat familiar. If you're not, go learn how to program. That's all I can tell you there. In programming, sometimes you have you're only wanting to allocate a specific amount of space to something. And if you have a program that's vulnerable to what's called a buffer overflow, that means that the space that you allocated is overfilling and overriding memory that you didn't originally intend to access. And so there's this thing called an instruction pointer. And if you cause a buffer overflow, the instruction pointer will move through the stack to a point where it will execute a specific return address. And then from there, at that return address, you can actually, whenever it hits that, anything after that, it will execute as well. So you could input your own code after that return address, and it would run it. So that's why it's important. All these different service packs have different return addresses to help you exploit this vulnerability. So if this machine is service pack 2 for some reason, this actually isn't going to work with this particular script. We'd actually have to either reverse engineer the Net API ourselves and find the return address on the service pack 2 machine, or we could cheat and dive into the Metasploit module where they've got like 20 million different service pack versions. We'll look at that later because that's really cool. But in the case of this script, if we don't have that return address, we're kind of screwed. So hopefully it works on service pack 3 English. Spoiler alert, it is option 6. Spoiler alert, it does work. We'll look at that, obviously. So yeah, that's why that's important. So what happens then is once we send over this buffer overflow, it's going to exploit this and hit that return address, and then after the return address, it's going to execute our shell code, right? All right, so we have these X90s here. This is called a Nmap sled. Why is it called a Nmap sled? Well, these X90s are non-operations, no operation. Don't do anything. Skip, move on to the next instruction. And we have a bunch of them. And the idea here is it's like a sled. So when you hit the return address, you could just put your code right after that. But if something's a little bit off, your code may get corrupted or something like that, you could have potential issues executing your code, and it's not so clean. So Nmap sleds allow us to kind of slide down into our shell code and also help us add a little bit or take away from memory, whichever we want to do. So these X90s are Nmap sleds. So the idea here is when we exploit this, it'll overflow everything and then hit the specific return address that we know it's going to hit, and then it will after that we'll execute our code, and it'll start with these X90s, and it'll say, okay, no op, and slide down into our shell code, which starts here, right here on this line. So they've given us some nice instructions in the comments, telling us how we can generate our shell code, what we need, making sure there's enough nops at the beginning, because there's a specific now. They figured this all out for us. It makes it a lot easier. They've even given us an MS Venom command on how to generate this particular payload. So this is why we need to know how to generate our own custom shellcode. You think, oh, why can't I just use this? Well, if your port's not 443 for your listener and your IP is at 192.168.40.103 right now, this isn't going to work. So we have to put our own IP and our own port in here for this to work. So we've got to generate our shellcode that's going to connect back to us. All right, so that's why that's important. Now we need to look at generating this. So, like I said, Metasploit's got all this stuff. Why can't we just use Metasploit? I've been talking about Metasploit and how great it is and how it makes this a lot easier. Why aren't we going to just use Metasploit? And we're also going to change something else too, this Meterpreter thing, because Meterpreter allows you to use Metasploit's functionality. We're going to change that as well, because we're not allowed to use Metasploit right now. Why aren't we allowed to use Metasploit? Well, sometimes you're not allowed to use Metasploit. So currently, I'm training for my OSCP. It's going to take me a while before I get to the point where I'm ready for it. 90% of that is because I'm in school right now. Like the rest of you all, I don't have time, but I am slowly training for it. And after I graduate, I plan to hit the ground running and start the pen testing Cali course. On the OSCP exam, you are forbidden to use Metasploit except for the few things I'm going to show you today. You're forbidden to use Metasploit. Also, I say except for the few tools. Also, you are allowed to use Metasploit on one machine that is specifically set. It's got like a flag and say, hey, I am the Metasploit machine. You can try it, Metasploit on me. So every other machine is not available. So if they give you a Windows XP machine and it's not the Metasploit machine, guess what you're going to have to do? Manually exploit it. You may even have to rewrite this exploit code a little bit to add in the custom return address. I'm not sure how dirty they would be to you on that, but you got to be ready for anything. Also, sometimes when you're doing a pen test, I've heard stories where clients will want you to not use specific tools, and sometimes they say, hey, don't use Metasploit. Now, whatever reason they have for that is whatever, but they may have that, and you've got to know how to do stuff without Metasploit. You can't use Metasploit as a crutch. You need to use it as a tool. So you need to know how to do this stuff without Metasploit. It's very important. In fact, the reason I'm even doing this is because I realize, MSO867's classic vulnerability is really easy to exploit, but I had only ever done it with Metasploit, and I'd been talking big game about how easy it was and how, I can just pwn any Windows XP machine, but you take Metasploit away from me, I don't know what I'm doing. I didn't know how to do it, so I was like, okay, I need to learn how to do that. That's a problem. So if you ever experience that, maybe it's time to learn how to, if you ever come across that conclusion like I did, maybe it's time to learn how to exploit something manually. Anyway, enough droning on that. We're going to run this in a subvenom command. We're going to change some stuff first. So what this is going to do is generate our shellcode that you see here, but we're going to have to change a couple things before we do that. So we're going to paste this command in, but we're not going to run it yet. So the first thing we're going to change is this payload. So the payload we're going to use is Windows shell reverse TCP. So the difference between shell and Meterpreter, shell just gives us a normal Windows command prompt. Meterpreter gives us a Meterpreter shell, which is a really fancy shell that gives us access to all the Metasploit modules, which is awesome, but we don't want to do that because we're not using Metasploit yet. Alright, so we changed that. It's going to give us a regular shell for our payload. Then we need to change our IP. So I'm going to change this to me. Then we say what port. So remember, this is going to help to look at this. We're doing a reverse TCP. So this is a reverse shell. So this is the port we're going to use later when we set up our listener. If you remember back to the Netcat Listener. So I'm going to do 1337 again. This exit fuck thread is another parameter that we wanted to add in based on the instructions that they figured out. And these characters are characters we want to exclude from our shellcode. They figured that out for us as well. And then this is a Python script, so we want to export this in the format of Python. You can actually exploit. So this is binary shellcode. You could export this as a Windows binary. You could also use a templating system and get the Windows calculator. This is lots of crazy stuff. You can get the Windows calculator app, take that binary, it'll extract that as a template, and then inject your shellcode into there. And so when they run the calculator app, it'll run just fine, but it'll also execute your shellcode at the same time, which is really scary, fun stuff. But we're not going to talk about that today. I highly recommend checking out Hack5's Metasploit Minute run by Mubix. Mubix does an awesome job. I have learned so much from that show, so I'm going to plug that real quick. So if you're interested in the Metasploit kind of stuff, go watch that, because you're not going to be able to get near as beneficial information from me as you will be from that. Anyway, like I said, we're not doing Metasploit. We're going to add one more argument to this, -v. Let's change the variable name. So before we run this, don't run this yet. I'm going to just show you guys. It's going to generate the shellcode, and this is what it's going to look like. This is the binary shellcode, but in the format of Python. So it's got all these buff, and this looks kind of familiar to what we had before. There's a problem, though. That's a variable name. We could, this is like a very simple problem, but I'm glad they have this feature implemented. Otherwise, it's kind of a pain in the butt. So we could do like a find and replace and change all the names to shellcode, or we can change in order to get this compatible with our program. But we're going to do -v. So -v is variable, and it stands for the variable we're going to use when we're generating this shellcode. So we want to do our variable name as shellcode because that's what it is in our exploit. All right, so we did that. Now we're going to copy this, and that's kind of it. We're done as far as the shellcode is concerned. We're not done yet. We have to paste this in. So we're going to delete all the way up to the last x90, and then paste in our custom shellcode. So this is our shellcode, and it's going to connect back to us when we run this program. So we're actually kind of done here for now. Now we need to set up our listener. So we could do a Netcat Listener on port 1337 like this. There's a couple problems with that. I think for the most part this would work, but I've experienced very wonky connections as far as this is concerned. So we're going to use a tool called we're going to use a tool called Metasploit. We're going to use Metasploit to do this. So to start Metasploit from the command line, you just type MSF console. So just to clarify, I said we weren't using Metasploit. It would look like I'm kind of lying right now, right? Well, so here's the thing. We're using tools that are available to you on the OSCP. So Metasploit's available to you, but you can only do certain things. For example, from what I've read, the multi-handler is always available to you. The multi-handler is like a Netcat Listener on steroids. It is awesome. It will handle multiple connections for you. I think it even handles encryption if you're using like an interpreter or something like that. Of course, in this case, we're not. It handles, you're able to background stuff and move around and all that kind of stuff. So it's really, really useful and a lot more stable than just a regular Netcat Listener. So that's why we're going to use it, because it's a valid functionality of Metasploit that we can use regardless of what we're doing. It's just basically a workstation for us to handle our incoming connections. And the normal Windows shellcode generated by MSF Venom is also valid to use during your CP exam. So that's why I'm letting us use these tools, is because they're completely valid and they make life as easy as possible, even though we're having to manually do a lot of stuff. So anyway, started up Metasploit. We're going to say use exploit multi-handler. So this means we're using the Metasploit multi-handler like I just described. It's going to handle all our reverse shell stuff. So we need to set the payload. This is going to be what we used for the generating our MSF Venom shellcode. So it's Windows shell reverse TCP. Then we're going to say set lhost, and that's going to be whatever your IP is. Then we're going to say set lport, and that was 1337 in my case. And if we type question mark, you can see different options that we can do in Metasploit. And if we just say options, we can see those specific options that we just set. So yeah, so we got our lport, our lhost, all that kind of stuff. So that's great and all. Now we can run exploits. If you just run exploit now, it'll start the listener, but I like to run it with a couple arguments. Do -z-j. This says, hey, do this as a background job. And what that lets me do is do other stuff in Metasploit while waiting for a listener. So I just do that by default for normal stuff, so I can do other things. I have that option. I like having that option available to me. It's not necessary, but I do that, and that's kind of what this looks like. So it starts the exploit running as a background job and starts the reverse TCP handler. Now whenever a session comes in, I will get a little prompt that says, hey, we've got a connection on here, and then I can look at my sessions and go from there. So our reverse shell listener is now running. Now we can go ahead and exploit the machine. So if I go to my desktop and I run python pwnxp.py, I get a lovely little help prompt. So sometimes this is really nice, because sometimes the public exploit code you don't get jack diddly squat. You have to deal with what you got and read exploit code. But this gives us some nice instructions. So it says usage. In my case, pwnxp.py will be whatever you named it, and then target IP. That's not entirely true. If you look a little bit closer, you do the exploit.py, the victim IP, or the target IP, and select an option. So like I said, we're going to cheat a little. The only reason I know it's option 6 is because I brute forced this until one worked. And honestly, it could have only been option 6 or 7, because if you recall from what we just looked at, if you don't, we can look at it again. Option 6 and 7 were the only two Windows Service Pack 3 options, or Windows 6 and 7. Yeah, 6 and 7. 5 is one too, but this is obviously not a French language variation of Windows XP. It's obviously English, because we got English feedback when working with it, and there was an English web server and all that kind of stuff. So it's obviously not French. So 6 and 7 are really our only two options. I know it's 6 because I tried it and it worked. And I tried 7 and it didn't work. So it's important to know this vulnerability is very, very not stable. I've had very mixed results. Sometimes I can reconnect to it like 12 times. Sometimes I blue screen it after the second connection. Sometimes the service shuts down even though the computer's up and I can't re-exploit the NetAPI vulnerability. We actually had a lot of technical difficulties with this during the meeting. So just keep that in mind. You need to be very accurate and precise when exploiting this, and don't lose your session. Do the maintaining access step if this is a real world scenario. But this isn't a real world scenario, so we're not worried about all that. So now we can get to exploiting. This is it, guys. We had .1.24, and we want option 6. All right. So as soon as I hit enter, I hacked this machine. Be sure you are doing this to a machine that you are allowed to hack. Ethics are important. You will get thrown in jail if you do this illegally. This is a VM I'm running on my machine. I'm giving myself full permission to do this, so please keep that in mind. That is very important. So with that out of the way, let's do this thing. Alright, so we're initiating connection. We've successfully connected, and the exploit's finished. Now if we go and look at our listener, look at that. Command shell session open on our victim. So you can view what sessions you have open, because you can have multiple sessions with sessions-i. In this case, we only have one. If we want to connect that session, we say sessions-i1. Alright, we're in. We own the Windows XP machine. That's how you manually exploit Windows XP using the NetAPI vulnerability. Alright, so that's all well and good. We can start like looking around here, poking around. You know, I'm in the Windows directory, the Windows, and I can look around, do some stuff here. This is that XAMPP. I could go around changing files. So just as a spoiler, I am root right now. This gives you system level privileges, which is awesome. Super scary and super cool and all that kind of stuff. But it's kind of hard for me to tell because who am I doesn't work, and this shell doesn't tell me what my privileges are. There's other ways to do that. I've tried doing it a bunch of different ways. In this case with this shell, it doesn't really help. But if you just start changing stuff and you'll notice you have permissions, you'll know that your system. That's the quickest way to know is to try. Alright, so we're going to abort this session, just hit Control-C, so that's done. We've hacked Windows XP. That was the whole point. Now I'm going to show you how to do it with Metasploit. So there's lots of ways to go about doing this. I think during the meeting I used Armitage to do it. I think that was kind of a mistake. We may double back and do Armitage again with this one. I don't know. It depends how I'm feeling towards the end of this video. But I'm going to actually exit out of Metasploit, and I'm actually going to pull it back up again. So, going to do that, and say MSF console, and I don't remember the vulnerability off the top of my head. That's what's great about Armitage. So Armitage is a GUI wrapper around Metasploit that makes life even easier. So yeah, I think I will touch on that just to show you how easy this really is. But I'm going to do it from the Metasploit console first, just for proof of concept. So I can really easily exploit this with just a couple lines in the Metasploit console without doing all the crazy stuff we did. So we're going to say use exploit Windows Net API maybe. So this is what I don't know. So that's where Googling is important. So yeah, we're on the OSCP. Kind of shied away from the PowerPoint a little. So keep in mind, Metasploit's a great tool, but it's not always available. So that's what I was saying. Make sure you can do it manually. It's not usable on the OSCP. If a client requests it, you can't use it. For pivoting, you may not have access to your tool set, especially if you can't set up proxy chaining and stuff like that. So you may need to be able to handwrite a script or something to do it. So yeah, that was the last slide. I've kind of already talked about that though. So if I Google Metasploit Net API Windows XP, it's going to help me out a whole lot and tell me how to do this. So Rapid7 are the people who make Metasploit. So thank you. We are going to look at how to do this. Okay, so yeah, use exploit Windows SMB MSO8067_net API. So if you aren't familiar with tabbing, you should definitely do tabbing. Tab auto completion in terminal is great. So that's how I'm doing all this fancy stuff so quickly. It even works in Metasploit. So what was it? MSO8067, MS08. There we go. All right, great. So that's the exploit we're going to use. We're going to set lhost to us. Set lport to us as well. Set our host, which is the remote host. So lhost is localhost, us. Our host is remote host, victim. This is going to be 124. Set our port is port 445. Right, so we can now say show options. There's automatic targeting. That kind of should be it. So now at this point, I think we can just say exploit, right? Looking at our reference. So yeah, let's exploit. So set those options. So all we did was open Metasploit, set those options up, and now exploit. And this should hack our machine. Alright, so this is a problem that I see, or this is a problem that I encounter sometimes. So we did automatic targeting, and it tried to fingerprint Windows XP as Service Pack 2 in language English. So it says 2+, but it didn't really work. And that could be for a lot of reasons. Let me check on the virtual machine real quick and make sure it's not like busted. Alright, so it's not busted. We may have to reboot it, and that's okay if we do, but we're going to try again with automatic targeting and see if it works. Alright, so we can say show targets then, and we want to specifically go after. So here's the cool thing about Metasploit. So we have all these targets, right? It's got all the Service Pack 2s, all the Service Pack 3s, Windows 2000, 2003, all the different Service Packs. It is fantastic. So yeah, we are going to want option 5, which was the same option we used. Ooh, not option 5, I'm sorry. Service Pack 3 is what we want. Where is that? No, Service Pack 2. We want Service Pack 3, English, and X. So yeah, this is what we want. So that's option 7. So if we say set target 7, then exploit should work. Alright, so exploit completed, but no session was created. Status pipe not available. Alright, so we're going to reboot our VM real quick and try again. Now remember, in the real world, you don't have this luxury unless you're right in front of the machine. In which case, if you're right in front of the machine, there's better ways to get it. Alright, so we're going to try that again. It's very possible that the IP of my victim has just changed, so I may have to run through our net discover step again. So let's do that. Oh, okay, it hasn't changed. That's good to know. All right, cool. Yeah, all right, there we go. Exploit. So yeah, like I said, this is a very finicky vulnerability, and sometimes you can't exploit it more than once, and that's just the way it goes. So now we have a interpreter shell. For the interpreter shell, you can do anything. So yeah, so let's ls say get UID, right? We are system, so we've owned this machine. We can do anything from here. We can do a hash dump time stop. We can say get desktop to return the current interpreter desktop. We can let's see if there's some cooler things we can do real quick. So this, I'm gonna show you guys in Armitage how to do this in a couple clicks, but it's literally the same thing. So I can drop into a normal shell, do sys.info. What's some of the scary stuff that we can do? So core command, background. Do upload. We can upload files. That's really cool. We can. Where is that one? Screenshot. Grab a screenshot of the corner desktop. For some reason, when I do this in Armitage, it never works. Let's see if I can do it just from Metasploit. Be cool if it works. Sometimes it doesn't really work. Yeah, okay, so that's okay. But the point is we got it, and it was really easy to do. We just set a couple options and said exploit. It's like in the movies. Alright, so we're going to exit, and now I'm going to show you guys Armitage. Armitage is just a GUI wrapper around Metasploit. So if I say cat, I've got a special script for running Armitage. So before you can actually start Armitage, you have to start Postgres. Share bin. What's my Armitage? That's not right. User local bin, right? Yeah. Armitage start. So this is quick script. All it does is start Postgres database and then run Armitage. So you can just start this. If you're using Cal, you can run this in the command line, start Postgres, and then you can just click Armitage and it'll work great. Otherwise, you can do the script and you can copy in the user local bin, says executable, and now it'll be in your path. And so every time I want to run Armitage, I just do this. Right? Look at that, my battery's low. So we'll need to finish this up. Alright, so we'll just connect, say start the RPC server, and it will take a second. Now, Armitage is a big, powerful program, just like Metasploit is. It's just Metasploit with a GUI on it. In fact, you'll see in a second, I've got the Metasploit console right here in this window once it loads up. So I can do everything Metasploit can do. It just provides a nice interface for you to do things a lot easier, right? So yeah, there's the Metasploit console. So we can even do like an Nmap scan from this database. See, there was a previous one. So I did a lot of cool things in the meeting that I'm not going to do, like the find attacks. I talked about Hail Mary, but don't do a Hail Mary. That's a very script kiddie thing to do unless, like, I can't lie, I love doing Hail Marys, it's just fun. But unless you know what you're doing, don't just do that across the network, because you're going to send a lot of traffic, and there's a lot of traffic running exploits. So bad things can happen. Alright, cool. So, yeah, so it's a big tool, just like Metasploit is, and it can do a lot of stuff. So I'm doing an Nmap scan with OS Detect. If you just follow through kind of like that I did, I went to host, Nmap scan, quick scan with OS Detect, which is exactly what we did before. It's going to this is just a full workstation to do Metasploit stuff, which is cool. It comes in handy a lot. So this is going to scan that machine, gives it the same feedback we got before. It's going to add this machine up here to the thing. Mine is kind of busted for some reason, doesn't automatically detect the operating system, even though it did down there. So I'm just going to mark it as XP. And now I can do a couple things. I can just go ahead and say MS08 067, kind of search for it over here. There it is right there, and I can double click it. Look at that, the option's already set. I can say use reverse connection, automatic timing, launch, and it'll work great. Alternatively, I can go up here to find attacks. It's going to pull up all the kinds of things I can do based on the operating system that's set over here for my target. So it's Windows XP, so it's just querying all the exploits in the database, and it's like, hey, here's what you can do. So all these crazy exploits, I'm sure more than one will work, but all we really care about is here. So we could actually come right here SMB, NetAPI, same thing. So yeah, and either one, it's the exact same thing. So I'm going to say use reverse connection, and now I'm just going to click launch. So in just a couple clicks, like 2 or 3 clicks, exploit failed. Connection was fused by the remote host. That's because, remember, we had some problems with it there. So we're going to reboot again because, yeah, so it looks like that process crashed on our victim here once we closed out of our interpreter shell. So we're going to reboot it real quick again. Thank you for save states. And we're going to double click, first connection, launch. And we did just reboot that machine, so it wasn't working. So let's cheat real quick. Alright, yeah, so it's still the same IP. So it's still connecting to the network, so just needed to give it a second. So we can try it again. Like I said, very finicky. VirtualBox, Windows XP, all that kind of stuff. So, alright, so it's rebooted. We've given it a second. Alright, so now, 2 clicks, launch. Ends up being less impressive than it was. Alright, cool. So we owned it in a couple clicks. We've got system access, lightning bolts, real cool. We got our interpreter shell like we did before. We can do a lot of cool stuff with this. So we can interact with that interpreter shell that we had. We can do some exploring, so we can browse files. We can, so there's easy to use file browser. If you like GUI, there's we could try to do the screenshot again. You can start doing key logging. You can show processes that are running. You can actually migrate between processes. This failed in the demo. I'm gonna try it now. So there's SVC host running as root. So if I'm worried about my NetAPI vulnerability being unstable and crashing, I can just migrate this process and pretend to be it. So okay, yeah, that was successful. Awesome. So I am now running as this process. So if somebody's on the computer and they kill my process that was running for some reason, say I used like a different exploit or was running a binary, and they kill that, I'm still on the machine. They closed my program, but they didn't get rid of me. I'm still here. And I'm pretending to be this program currently. That's freaking awesome. That's some like black magic right there. So yeah, lots of stuff I can do. One thing you may be interested in is maybe a desktop VNC. Hopefully I can get this to work in the demo as well. So we're going to try to execute the desktop VNC session. So it says, hey, we are to connect here. So what it does kind of relays back and says, okay, we've got like a viewing server set up for you at your local host on port 5972. So we are going to open that up. Oops, need a different terminal. And we can say VNC viewer 127.0.0.1 colon whatever port was specified, which in this case was don't know, 5972. 72. It's going to start our VNC viewer, and there we go. It worked this time. So there is our VNC desktop. We can click around, and we have a nice Windows XP interface. It's really slow, but it works. So there you go. That's how you hack Windows XP in every sense of the idea. So a couple clicks, hacked it. Execute a couple commands, hacked it, and even the more complex manual exploitation wasn't really all that crazy. It took some fundamental concept explaining, but if you knew how to do that already, it's literally generate shellcode, paste it in, start a reverse shell handler or a listener, and execute Python script, and you're in. So yeah, that's how you hack Windows XP. That was the hands-on activity for our meeting. Thanks for watching.